In the Unit 1 Day 3 notes, we're going to continue on with our algebra review, which includes more factoring. Yesterday we did GCF factoring. Today we're factoring binomials and trinomials. The binomials that we're factoring today are going to be those that are of a dot pattern. And dot stands for difference, meaning it must be subtraction, of 2, meaning you have to have two terms. And both terms have to be perfect squares. That's where the S comes from. Numerically, if you're working with a number, that means your number has to be a perfect square. If you're working with a variable, you have to have even exponents. If they're not even, you can't factor using dots. When we factor this, it goes into two sets of parentheses that look identical except the middle sign. One of them is going to be positive and one of them is going to be negative. So when I'm looking at question 1, I acknowledge that it is a difference problem because of the subtraction. There's two terms. The numbers that I see in there are perfect squares. The exponent is even. So that means that it meets all the criteria of a dots problem. I'm going to do two sets of parentheses. I'm going to square root the first term. The square root of 4 is 2. That fills both parentheses. The square root of x squared is x. That fills both parentheses. I'm going to square root 9 and get a 3. So the last term in the problem gives you the last term in both parentheses, and one of your parentheses is positive and one of them is negative. It's literally as easy as that. Question 2 might look more challenging, but it's only because the numbers are bigger. It still fits the criteria. The numbers I see are perfect squares. The exponents are even. When you are square rooting a variable with an even exponent, the rule is that when you square root it, you take the exponent and divide by 2. So the square root of x to the 14th will be x to the 7th. We can apply that here because I'm going to have two sets of parentheses. I'm going to square root the first number, the first term, which will give me 10, x to the 4th, which means my second parenthesis is also going to start with 10, x to the 4th. And then I'm going to square root my second term, 7y to the 5th, 7y to the 5th, 1 plus, 1 minus. Doesn't matter the order that the plus and minus go in. Question 3 is actually an easy one. All we have are variables with even exponents, so when I go to factor this one, in question 3, it's y and z and 1 plus and 1 minus. In question 4, this one's here for one reason only, and that is because sometimes kids will think that they can interchange the order of the 1 and the m. You can't do that. So in other words, if you are going through to factor this with GCF, when you square root 1, you get 1. Because 1 starts the problem, 1 has to start the parentheses. Square root m squared, m, and m. 1 plus, 1 minus. They ask you in questions 5 to 8 to factor those perfect squares. I'm going to give you a minute to pause this video, do that on your own, and then come back and check your answers. So my answers are written here for those questions 5 through 8. Please take a minute and check those answers. If you need to pause the video to check them, please go ahead and do so. Questions 9, 10, and 11 are there because they're common mistakes. People commonly mistake them as being dots questions, and they are not. So they are not dots questions, and we're going to talk about why they're not dots questions so that you aren't tempted to make that same mistake that other people make. In question 9, it is not a dots question because the x is to the first power, and we know dots only works on even exponents. So for my reason, I'm going to put not an even exponent. In number 10, it is not dots because dots stands for difference of two squares, and we don't have a difference here, we have a sum. So I'm going to write down that this is not a difference. In question number 11, it is not a dots question because 2 is not a perfect square. If we had something like 25 there, that would work, but not when there's just a 2 there. So that will not work. So I'm going to put a note here that says 2 is not a perfect square. So using dots is very specific. You have to make sure that you're meeting the criteria: difference, two terms, both of which are perfect squares. When we continue on with our review today, we're going to be doing some trinomial factoring. There's two different kinds of trinomial factoring. One of them is when there's just a 1 in front of the x squared. These are the easy ones because you're looking for numbers that add to 9 and multiply to 14. So we've got that add multiply situation that goes on here. Those are usually the ones that everybody's pretty good at. So when I'm working on question 12, if I was to list out my factors of 14, if you wanted to, numbers that multiply to 14, I'm going to pick to use 2 and 7 because they also add to 9, and I need a 9 for the middle term. So to get x squared, I have to have an x and an x. To get 14, I have to have a 2 and a 7. The only way I'm going to get a positive 9 in the middle is if those are both positive. When I go on to the next question, I want numbers that multiply to 14, add to 15, so obviously we're going to use 14 and 1. To get the x squared, I need x and x. To get the 14, I need 14 and 1. And the only way I'm going to get a negative 15 is if these two are negative and I add them together. Think about it though. If those are both negative and I multiply them, it gives me the positive I need right here. So in these questions, so on the last question on this page, number 14, we're looking for numbers that multiply to 18. My numbers for 18, clearly 18 and 1, 2 and 9, 3 and 6. In this case, the last term is negative. It's numbers that multiply to give me a negative 18. So that means that I want to look for numbers that either add or subtract to the middle term. And 3 and 6 will subtract to the middle term if I have the signs arranged correctly. So this tells me that my signs will be different. This actually tells me what my bigger number will be. So my bigger number, 6 or 3, is 6, so that will be negative. If my signs have to be different, then 3 has to be positive. And if you keep that in mind, that tells you exactly how to fill your parentheses. So one of my parentheses is x plus 3, one of my parentheses is x minus 6, and those numbers do meet the criteria. If I add positive 3 and negative 6, I get negative 3. If I multiply positive 3 and negative 6, I get negative 18. In question 15, we're working the same way. I want numbers that multiply to 35, and they have to add to 2. This negative tells me that they have to be different signs. This tells me, once I determine my numbers, what the bigger number is. And because the signs are different, the other number by default has to be negative. So in this case, the numbers that multiply to give me 35 are 7 and 5. Those are the ones that I'm going to pick. The signs have to be different. 7 is bigger. Because 7 is bigger, it will carry this positive sign. By default, then, that's going to be negative. So when I go through to factor this, I have m plus 7 and m minus 5. I'm going to give you a couple minutes to pause the video and do question 18, 19, and 20, and then you can come back and check your answers. Please check your answers for 18, 19, and 20. If by chance you need another moment to check them, please feel free to pause the video again. The reason why I left questions 16 and 17 to come back to is because they are still trinomial factoring, but they're a little bit different. In these, you will notice that the leading coefficient is not just a 1, which means we have to have another process to go through and do the factoring. I'm going to use the process called split the middle. That means I'm going to essentially be splitting this middle term up into 2 parts. In order to do that, I have to take this leading coefficient and multiply by the 15 to get 30. I am looking for the factors of 30 that will add to 13, the middle number. I am going to use 10 and 3 because 10 and 3 multiply to 30. So instead of having 13x, I'm going to rewrite this question as 2x squared plus 10x plus 3x plus 15. So I took the 13x and wrote it as 10x and 3x. And then I'm going to split this into two parts. I'm going to do GCF on both parts. On the first two terms, I can take out a 2x and be left with x plus 5. On the second two terms, I can take out a 3 and be left with x plus 5. And then I'm going to look at these as two terms. And when I say to you, what do those two terms have in common, you should notice that they both have an x plus 5. I'm going to take that out of both of them. And when I take that out of both of them, what I have left is a 2x plus 3. That goes in its own separate parenthesis. And that is how you can factor number 16. If you would prefer to do guess and check, that is totally fine. Some of the middle school teachers teach something called slip and slide. That's fine as well. Question 17 is the same kind of question. 6 is a leading coefficient and it is not a GCF. So I'm going to take the 6 and multiply by the 2 and it's going to give me a 12. Theoretically speaking, it's a negative 12. I'm looking for numbers that multiply to 12. I can use 4 and 3, 2 and 6, 1 and 12. I need to have the ability to split this middle. So I'm looking for numbers that somehow can be split up to create a 1. The numbers I'm going to use are 4 and 3. This tells me that my signs must be different. This tells me what the bigger number gets. Same rule. The bigger number is 4, so it's positive. By default then, if the signs are different, this is negative. So when I go back through to split the middle, I write down the 6x squared. Positive x is turned into plus 4x minus 3x minus 2. I regroup the way I look at these. When I look at the first two compared to the second two, the first two can take a 2x out of and be left with 3x plus 2. The second two can have a negative 1 factored out, and I'm left with 3x plus 2. At this point, I look at these two terms and I say, what do these two terms have in common? They both have a 3x plus 2. I'm going to take that out of both of them. When I take that out of both of them, what's left? 2x minus 1. And as soon as you do that last step, you have gotten your trinomial to be factored. I'm going to do question 21. I'm going to ask you to pause the video, attempt it on your own, and then come back and push play, and I'm going to work through those steps. I'm not going to talk about the steps as I work through it. I'm just going to go through and do them so you can sort of check your work as you go.